Hey, welcome. In today's quick concept video, we're going to talk about an aspect of DevOps called continuous integration and continuous delivery. CI/CD has a number of benefits, and we'll talk about those benefits in this video. The goal is to at least hit the wave tops of all the important parts of CI/CD. If you enjoy content like this, like and subscribe. So if we look at an example of what a software development process might look like, it may have these particular steps, where it starts off in development and we do the actual software development, we do testing, then we stage it, and then at some point it transitions over to the operations, and then there's some integration and some testing and some deployment, and then maybe some release management on that side. And then ultimately the operations team is responsible for monitoring the application. The software development process is a pipeline. For taking words, which are requirements, and converting them to production quality code. Traditionally, those tasks that are associated with development have been kind of siloed and done by the software development team, and those tasks associated with operations existed in another silo, and those were done by the operations team. For example, if you take a look at the development tasks here, this isn't a complete list, but these are some of the more common things that you'll hear software development teams talk about. They'll have a process like Agile, Scrum, you'll hear Kanban, Lean. A lot of times you'll hear architectural design being tossed around, or the team also has some documentation kind of tasks or responsibilities, documenting software architecture or requirements and things like that. Generally, we start off with some high-level feature requests, and as software developers, we break those features down into chunks, so we call them tasks. Those smaller tasks may even be broken down into subtasks, but once we get down granular enough, it's usually easier to provide kind of estimates. And so there's that work breakdown process that software developers are familiar with. Version control is another thing that software developers talk about. So we also incorporate principles like solid or dry or Yagni, and we also incorporate software development patterns. I've listed two here, Factory, Singleton, but there's a whole book on kind of common patterns. And one of the challenges as software developers, as we kind of mature, we learn how to use patterns and which pattern to use when. Generally, software developers have a build process. So how do we build our application? A lot of times it's on our dev box, so we're building it on our dev box. We're getting some working kind of code on our machine. So it works on our machine. That's what we're trying to get to. Another activity you might hear software developers talk about are code reviews. As a software developer, I'm not perfect, but the more eyes I get on my code, the better that code generally becomes. So I can learn by other people's analysis and kind of improve my code. And it also makes me better just generally as a software developer to get that feedback. And testing is really important. On the development side, usually there's unit level tests. I talked about breaking those features down into tasks, but maybe those subtasks have like a test associated with them. That test makes sure that subtask works, and then every subtask has its own test. So at a unit level, that small granular level, we're running tests. Another level of testing that generally happens is acceptance level testing. We work with our end customers, or maybe our product owners, or whatever you call them on your team, but they develop some acceptance level tests. And if the code passes the acceptance test, then we know that it's meeting their needs. And then the other side of the house is these operational tasks. Again, an equally long list. And they also have some kind of process that they're following. Maybe they're running Agile, but sometimes, these operational tasks are on the IT team. So the IT team may have kind of a ticketing system or some other way that they're kind of generally doing their development. At an operational level, when we start to really talk about production, it's important that our architectural design and implementation is well thought out and can handle kind of the loads that we're seeing on our servers. So on the operations side, architecture is extremely important. I do think that this is one area where the architecture is generally shared on the development side across to the operations team, so that we can have the same expectations of kind of where we're going to deploy and what that's going to look like. On the operations side, again, there's documentation, there's infrastructure that's there, physical, either on-prem or maybe it's in the cloud, or maybe it's some kind of hybrid of on-prem and cloud, but there's some infrastructure that has to be taken care of. On some operational teams, you're going to hear them talking about infrastructure as code, so that they can easily spin up new infrastructure just by kind of running some code. So security and our compliance, if for any kind of regulatory aspects, like if it's a credit card industry or whether it's HIPAA or medical device, whatever that is, if there's some kind of security or compliance, usually we need to make sure that our servers are up to date with the latest and best practices for security. On the operations side, there's also the final integration into production. So what does it really look like? Are we running against the production database? Are we running against the production queue system? Maybe I have a RabbitMQ server that's sitting out there, and now I'm integrating with the RabbitMQ server. And so that final integration and those final tests need to be run. Again, there's acceptance testing by the end user to make sure that it's meeting their needs. Another concept on the operations side is release management. Oftentimes, there's a very formal process for releasing and kind of labeling these releases. So this is officially version 2.1.3, and it officially gets pushed out into production. Another huge aspect of the operations side is the monitoring, and really kind of pushing towards observability and making sure that all of the servers and the running applications kind of emit enough kind of telemetry so that we can have dashboards and see what the status of everything is. And not only that, but when the status kind of fails, or it should raise a flag, and then we can get alerts. But the operations team is generally on call 24/7 to make sure that that application is up and running. Incident management is also important. So if there is an incident, if a server goes down for something, obviously, priority number one is get the server back up and running. But then there's usually some kind of retrospective that happens to try to understand, what was the root cause of that incident and how can we do better in the future. And then we start to get into aspects like availability and scalability to make sure that our systems, our servers are handling the loads that are presented on them. Finally, the backup and recovery system. That can be very complex, and especially if you're on-prem and you're trying to manage everything yourself. I think it's a little bit easier in the cloud when you have different availability zones and you can deploy to different areas. But for example, if you're on-prem and you're in Florida, and you have to kind of handle these natural like hurricanes coming in, and you're going to have power outage for days. How do you manage your production system and make sure that that thing stays up and running? So now that we've taken a look at kind of the traditional kind of silos, let's take a look at a more modern approach, which is, what we call DevOps. And things are not necessarily siloed, but we're starting to kind of blend things together a little bit more, especially when we take a look at continuous integration and continuous delivery. One of the key goals is to kind of streamline and speed up the software development process. And this is accomplished a lot through the automation of different tasks. Here's a list of CI/CD kind of tasks that generally happen. That ability to easily kind of have these pipelines where we can spin up new infrastructure is important. Another common task is to automate things. You automate your builds, your tests, all your deployments. So you can just kind of have a single button and you can click, and you can have like a triggering event, like you just push new code into a repository. And then this workflow automatically kicks in and it does the build, it does the test, it automatically deploys to your testing environment. Having all of that automation and being able to kick off workflows where these things are chained together is a super powerful mechanism for developers to, for example, check in new code, and then that new code can kick off a build process or build steps. It can kick off automatic unit tests, and it can automatically be deployed to kind of a testing environment. And then on top of all of that, if any tests have failed, I can get an automatic notification back to me saying that, hey, you checked in code and you broke the build. Having this mechanism in place really encourages developers not to check in large bulk amount of code at one time, but to kind of check in small little increments, because we always want to make sure that our build is green, and we're just trying to keep the builds green all the time. One really super important thing about this CI/CD pipeline is that there's a single build. So what we're not trying to do is build it once, build it for the dev system, rebuild it for tests, rebuild it for prod. What we do is early on in the pipeline, we create a single build, and then we can deploy that to the dev system. We can deploy it to the test environment. We can deploy it over to our production environment when we're ready to go. When we start to automate tests, one of the questions that come up is, code coverage. Are we covering code? And, chasing the 100% code coverage can be daunting. It can be kind of a waste of time sometimes. So what we want to have is some smart code coverage where, we are testing the most important aspects or some key integrations or something like that. So all of those kind of real critical areas are absolutely getting tested. And that way there's a kind of a balance between writing tests and writing code. If the developers are always chasing 100% code coverage, they can spend a lot of time writing tests and less time writing code. So there's a kind of a balance that we're trying to get. And, choosing what to test and where to test it is important. One of the other key aspects of CI/CD, especially in the production system, is that there's only one way to get a new release into production. And it's certainly not by someone logging into production and like fine-tuning things and twiddling on things. So either we purposefully click a link or we have some event that pushes to production, but there's only one path to get to production. Just generally for DevOps, we try to take all those operational tasks and we can shift those left as much as we can to the development tasks and get them done early on in the process, because that tends to mitigate a lot of risks, and mitigating risk is always important in the software development pipeline. So ultimately, when we're all done, we want the CI/CD pipeline to be automated, repeatable, fast and easy, and give us this kind of monitoring or this green light that just automatically, when I push code, I can see, I didn't break the system, it's still functioning. And having that kind of system as a backstop is a very powerful environment for a software developer to write code more freely. They know that they're not breaking things. And this is especially true for developers who maybe don't really know the full code base, and they're writing a piece of code, but they're not really aware of maybe some integrations that have gone on. And so when they push this code, it really helps them kind of have this backstop. There's a lot of effort that goes into kind of those automations and building that pipeline. So what do we get back in return? So one of the things we get back in return is faster time to market. Because we've automated the building, the testing, all the deployment, it allows developers to kind of quickly make changes and check those changes in and be assured that they haven't broken anything. And so we can have these rapid kind of delivery cycles that are happening between a developer and the operations side, so we can quickly fix bugs or make little small improvements. Even in the kind of a staging area or an integration area, we're building new features, we can quickly iterate on those features and build those up. Another benefit is improved software quality. By having automated tests and encouraging developers to write tests, we're really kind of setting a culture that we have standards that are a little bit higher, and we're trying to make sure that our software is going to meet those standards. Another benefit is enhanced collaboration and communication. By taking the silos down and mixing those development tasks with the operational tasks, we can better provide visibility into what we're trying to accomplish. And the operations team doesn't get a last minute notice that, hey, by the way, you need to upgrade the server to version whatever. It's more upfront, and that whole visibility and collaboration happens a little easier. There's an element of reducing risk and kind of increasing stability of our code base by having an environment where we're encouraging developers to check in incremental changes, and having those incremental changes automatically tested, and we get the green light. We understand kind of where our system is at all times. And when a developer breaks the build and that build isn't green anymore, then that developer has an urgency to kind of get that build back to the green state and fix whatever bug or issue that was introduced with that last check-in. And finally, scalability and efficiency are increased. Just the ability to have infrastructure as code and be able to kick off a pipeline or a process to build like a dev environment, that generally can be a daunting task for a new developer who doesn't really understand how to provision an Ubuntu system, for example, and set up the Nginx server and deploy the code to it. By having infrastructure as a code that they can just run, now you've kind of empowered that developer to take ownership of their own development environment and making everything a little bit more efficient with them. So when you look at all the CI/CD tools that are out there, almost all of them have some concept of a workflow or a pipeline that you build, and ultimately there is some trigger that starts the whole process off. So when a trigger happens, a job gets kicked off and there's steps on the job that happen. So maybe the build step has a checkout and then the build, and then we're going to scan the code for like a security scan or something like that, or code quality scan, and then we're going to archive that build off. And then that could lead to another job, for example, a test job, which you fetch that archive, you unpack it, you set up a testing environment, and then you run those unit tests. And then you kind of put the test results, in an archive that's accessible also. And then finally, maybe that test job kicks off a deployment job to maybe a testing environment. And again, we start off by fetching that same archive that was built in step number 1. We copy it, maybe use an SCP over to a server, and then we unpack it, and then we deploy that. And then all along when these jobs get kicked off, if anything fails, say for example in job number 2, which is the test job, if there's a failing test, then job number 3 never gets executed. The whole pipeline can stop, and you'll see like a indicator on the CI/CD tool where it's a red bubble or something indicates that something has failed. And then a lot of CI/CD tools also provide some notifications. As a developer, if I checked in code and I caused the build to fail, job number 2 would send me an email saying, hey, that last thing you checked in, this is the test that has failed. And then if we just take a look, there's a lot of tools out there. I mean, there's a lot more than what I'm showing here. But for example, you have Jenkins, which has been around for a long time. It was previously called Hudson. I used it when it was Hudson. But Jenkins has that concept of having pipelines. There's Bamboo, which is an Atlassian product. There's GitLab, which has its own kind of CI/CD tools. Circle CI. GitHub has workflows where they have actions that you can kind of build. Travis CI is around. JetBrains has TeamCity. And there's a lot of other tools out there. So some of these can be hosted on-prem, so you can host them yourselves. Some of them you can host up in kind of a managed environment, so they're actually managing the CI/CD environment for you. But there's a lot of options for you to check out from. And finally, as always, you see these benefits here. Those benefits don't come for free. You have to put some effort into kind of building your CI/CD system. It's kind of like any other bits of your architecture for your system. It's an important part, and you want to treat it like that. So pick your tooling that you want to use, really learn that tooling, figure out how to create a pipeline or a workflow, and figure out how to automate your production.